Hello everyone and welcome to this video. So in this video we're going to be looking at a different type of classification evaluation metrics. So we're going to be looking at a different one. If you haven't watched the previous video, please watch that so you can catch up with what we're learning today. So let's start. So this is where we left off in the previous video. We learned how to use the accuracy evaluation metrics, and today we are going to be learning how to evaluate using area under the receiver operating characteristic curve. Okay, so that's quite a mouthful, but you'll understand it as we go through. So it can be known as AUC, area under curve, or ROC, receiving operating characteristic curve. So yeah, hang on, I'll just put these two extra. There we go. So now that we have done that, we should actually be putting more text underneath. So we're just going to list these. So we're just going to put area under curve so we know that's AUC, and then there's also ROC curve. And you probably know what that means because there's capital letters here, so ROC, that will obviously stand for that. So we're going to define what it is down here. So we're going to say ROC curves, or ROC curves. I like saying ROC curves because it's much easier. So our ROC curves are a comparison. So they're a comparison of a model's true positive positive rate, so you can say that's TPR, versus a model's false positive rate. So you might be going like, what is true positive rate and false positive rate? I've never heard of that before. Well, you probably haven't. So let's just say, so true positive rate, or just true positive, is actually when a model predicts 1 when the truth is 1. So maybe in maths you might have heard of something like a positive integer. That's a number of 1 or more. So that's why it's called true positive. So because it's the true positive integer or just true positive number. So when a model predicts 1 when the truth is 1. And then we've also got false positive. You've probably guessed what that is. So false positive is when a model predicts 1 when the truth is 0. So now, after that, we have a true negative. You might have guessed what this is because in math there's also something called a non-negative or negative integer, and that is basically 0. Okay, so true negative is, you probably guessed by now, when a model predicts 0 when the truth is 0. And then last of all we have false negative, and this is pretty easy now. So when a model predicts 0 when the truth is 1. Okay, so we can press shift enter and we have all of those lovely bullet points there. So the first thing we want to do is we want to create our train and test sets now, because this won't work unless we have it, okay? And it's much easier as well. So we're just gonna go xtrain. Actually, let's put a comment here to be a bit more communicative. So we're gonna just create our xtest or etc. Okay. So let's go xtrain, xtest. So remember, you have to keep in this order: ytrain and ytest. And we're just gonna say train test split. Hang on, let's just put the T in here. Train test split. And then parameters we need to pass in is x, y, and our test size. And that is equal to 0.2. So we've created those now. Now we can actually sort of make the predictions, and then we can create our false positive rates and true positive rates and all of those things. So I'm just gonna say from Scikit-Learn dot metrics import ROC. So import ROC. So that is actually in lowercase. So ROC curve. So the first thing you want to do is you want to fit the classifier, because we haven't done it yet. But if you're using cross validation, it already does it for you. But we're not going to use that anymore. We're going to use a different evaluation metric. So we're going to say clf dot fit xtrain and ytrain. And then we're also, after that, we're going to make predictions with probabilities. So what I mean by this, so probabilities, I need to spell these correctly. There we go. Probabilities. There. There we go. So, sorry about that. So, we're going to be using predict prober for that, and it sort of so what predict prober does is, you'll see in a minute. So we're going to say y probs or y probabilities is equal to clf dot predict prober, and if we just push shift tab, what we need to pass in is we need to pass in just x. Okay, so we're gonna pass in x test, and then what we're going to do is we're going to view y probs. We're going to view the first 10. So what predict prober does is, let's say this is, I believe, 0, and this is, I believe, 1. So that's 0, that's 1, and it just tells you what the probability is of getting a 0, or what the probability is of the machine getting a 0 or a 1. So we can use this to create a true positive and false positive rates. Okay, so now we can let's just view the length of this. Okay, so that is actually 61, and that is the length of our X test. You can check yourself. So we're gonna create our true positive rates now. So y probs positive. So y probs positive is equal to y probs, and we're going to be using slicing for this. So that means we're going to take away the first column. So slice the first column, sort of thing, and then we're gonna just view y probs positive. We're gonna view the first 10 because we don't want a huge list, and then there we go. We have now got these first results over here. Second result, sorry. So now we have to calculate the FPR, the TPR, and thresholds. So thresholds are what we're going to use. So here I'm just going to calculate FPR, TPR, and thresholds. Okay, so FPR, TPR, and thresholds is equal to ROC curve, and then we're going to pass in Y test, and then we're going to pass in Y probs positive. And let's just put in the T there. And then once we've done that, so you might be thinking, how do I know this? So first thing we're going to do is we're just going to, so I knew this because I looked at the doc string. So it just says Y true, Y score, and that score would be our Y probs positive. So now we're just going to actually check the false positive rates. Check false positive rates. And then we're just going to put in FPR. So those are our false positive rates. So this isn't a very ideal way to look at our ROC curve. So you'll actually see the curve if you look at it visually. So we're going to actually use matplotlib for this, and we're going to create a lovely function that lets us plot our ROC curve. So here we're just going to write create a function, for plotting ROC curves. Okay, so you can use this for anything, and we might use this later on, who knows. So def plot ROC curve, so we're just going to keep the name nice and straightforward. So it will take in FPR and TPR, and then we're just going to put a nice doc string here, so whoever's using this function knows what this function does, and we might not know what it does after a long time, so we can just check. So we'll just go plots a ROC curve given the false positive rate, and that false positive rate is FPR, and the true positive true positive rate, and that is known as TPR. And then there we're just going to put of a model. So now that we have done our nice doc string, we are actually going to get into plotting stuff. So we're going to go plot ROC curve. So we're just going to say plt.plot, and then we're going to pass it. So FPR. Let's just press Shift Tab to sort of remind ourselves what it does. So plot Y versus X as lines and or markers. So what it takes is it takes X and Y and the and it takes the format, etc., etc. So that is the X data right there, and then TPR, and that's the Y data. And then we're gonna just put in a color of our curve, and we're just gonna put that as orange. And then we're going to just label that plot. Label is equal to ROC. And then now what we want to do, we're going to do plot line with no predictive power. So this is basically sort of like a guess line that us humans would have guessed if we were trying to predict a ROC curve. So this is sort of like a baseline to see the comparison. So I'm going to say plt.plot, and we're gonna do 0, 1, 0. Hang on, we need to put that in a list. 0, 1. And then we're gonna do color is equal to dark blue, and then we're going to put line style is equal to, and I'm going to put a dashed line. You can put a straight line, but I'm just going to do a dashed line so it sort of differs from our actual prediction. And then I'm going to say label is equal to guessing, or guess. So that's our guess line, and now let's just make our plot more comfortable to look at. So we're going to go customize the plot. So how do we do this? We go clf dot x label, clf dot x label. So we're going to say false positive rates, because remember how I said that FPR was X and TPR was Y. So false positive rates, that's our X label. But first in brackets, I'm just going to put in FPR, and then I'm going to do plt.y label, and that will now be true positive rate, and that is TPR. I don't know why, but I keep on spelling positive wrong, and it's annoying. So now that we've done that, we're going to just put in our title. So plt.title, and I'm just as a title, I'm going to put in receiver operating characteristic, and then I'm going to put ROC in brackets curve, and we're just going to put in a legend. So plt.legend and plt.show. So that is our function done finally, and we're gonna say plot ROC curve, and we're gonna pass in our false positive rate and our true positive rate. So this, okay, have gotten a error. Attribute line 2D has no thing called label. Well, that is because we spelled it wrong. There's no property color. Oh, we just have to remember that they use American spelling here. Actually, so I'm just gonna go ahead and correct these, and then I'll be back. Okay, that's just because we need to put the American spelling for all of them, and name plt.legend. Okay, so we should be more careful. So now we've got our receiver operating characteristic curve. So this is the actual ROC curve, and this is just the guessing line. Okay, so basically if humans were to guess, they would probably guess like this, and it's just a fair line, but this is the actual way our model is predicting. So let's just take away the this line for now, and there we go. So let's just take it away and run it, and now that's gone, and that's fine, it's not going to disturb us anymore. So now let's actually sort of take in from this how well has our model predicted. So we're going to say from Scikit-Learn.metrics import ROC Score. So what ROC Score means is basically so area under curve. So we're going to be looking at the area under this curve, and that will be our score basically. So I'm going to go ROC Score, and I'm going to put in y test, and y probs positive. And now we should be able to view our score. So there we go. We have actually, this is the actual score that we will probably get. So maybe if we go up here, so we're just going to go up here. So yeah, that is about the same score, really. So basically, now we're going to look at what a perfect ROC curve would be. So basically, the highest score you can possibly get is 1. So we're going to be looking at how that would look like on ROC curve. So here I'm just going to say plot perfect ROC curve, and AUC score. So I'm going to say FPR, TPR, and thresholds is equal to a ROC curve. We're going to pass in y test, and we're just going to pass in the truth. So y test, and then I'm going to say plot ROC curve, and then I'm just going to put in FPR and TPR. So that is what a perfect ROC curve would actually look like. And then we can just view a perfect AUC score now. And we can just do this by just again saying ROC score, y test, and y test. So that is 1. So this is actually the end of this video. It was quite a long video, but hopefully I covered everything that you need to know for now about ROC curves and how they can help during evaluation. So, and yeah, how you can visualize them as well. So if you like this video, please like and subscribe. That would really help, and I would appreciate it. And if you have any doubts, please comment them in the comment section below. And as always, thanks for watching this video. Bye.